Alright, kiddos. So hopefully you did notice I changed Thursday's assignment from graphing quadratic functions C to graphing quadratic functions D. The reason was, in order to do C, you actually needed to know how to factor quadratic equations where A was not 1. And we haven't done that yet, so we'll get to that after the break. But for now, let's just stick with problems where A is 1. I'm going to go ahead and do problem 1. And what's different here than what we've done over the last 2 days is instead of making a table, I'm going to graph all the special points for a parabola, and that'll be enough to draw my parabola. Now, generally we need 5 points to make a parabola. 4 of those we can calculate very directly, and those are the vertex, the x-intercepts, which there are 2 of, and the y-intercept. And what we're going to do is then, to find our 5th point, we're going to use the axis of symmetry. You know what? I said I was going to do number 1, but let's actually do number 2. And I just made that change because I'd like to look at the negative. So let's go ahead and get started. If I want to graph this, let's go ahead and identify A, B, and C. We should really always be doing that when we are dealing with quadratics, at least quadratic trinomials. Here A is 1, B is 2, C is -3. So if I wanted to find my vertex to start with, before I do that, I need to use my axis of symmetry equation, -b/2a. I want to point out to you that at this point you really should have that memorized. I'm going to plug in the numbers -2, I'm sorry, +2, so it's going to be negative parenthesis +2 on the top, and the bottom's going to be 2 times 1, since a is 1 on the bottom. This simplifies to -2/2, which of course simplifies then into -1. So the axis of symmetry is -1. Now before I do anything else, I'm going to plot x equals -1, the vertical line on my graph. So again, what does that look like? Now the line x equals -1 starts on the x-axis at -1, which is here. And we're not graphing the point like a number line, we're actually drawing a vertical line. And we did this last Thursday, if you're keeping up with the work, if you're doing it on the right days instead of doing it all at the same time. Sorry about that. Okay, so again, we just graphed this vertical line. Now we're going to find and graph the vertex as well. So I'm going to take my -1, I'm going to plug into my original equation, which is over here. So that'll give me y equals, what was that equation? X squared, so I have -1 squared plus 2 times -1 minus 3. Let's move over here where we see this better. -1 squared is +1, 2 times -1 is -2, and minus 3. That cleans up to be -4. And that means my vertex is the point -1, -4. And of course, we knew that the vertex was going to be on the axis of symmetry, so we can find that right here. Again, I'm going to count over 1 back, it's -1, and then down 1, 2, 3, 4. That point's going to be here. Draw nice and big so I can see it, and then I don't need that stuff. Alright, so we have our vertex, we have our axis of symmetry. The next thing we're going to want to do is actually factor this thing to find the x-intercepts. And again, we did do this before, this is not new. I'm going to use my magic x over here with a times c at the top and b at the bottom. In that case, a times c, 1 times -3 is -3 on the top, b is +2 on the bottom. Now, to make a negative number on the top and a positive number on the bottom, I know one of my numbers has to be positive, one has to be negative. In this case, it's going to be a positive 3 and a negative 1, where 3 times negative 1 is negative 3 for the top, and 3 minus 1 is positive 2 for the bottom. Which means my factored form looks like x plus 3, x minus 1. Now, remember, the original equation said y equals this. I'm going to change that y to a 0. And again, why do I do that? You may need to look back at an older video, but the reason this works is the x-intercepts are exactly the x values when y equals 0. That's why I'm allowed in this case to change the y. I'm substituting 0 for y. And I've also moved it to the other side just because it's how I like it to look. Now I'm going to use the zero product property. Plus 3 minus 1. X plus 3 is equal to 0. And x minus 1 is equal to 0. So when I subtract over here, I get one x-intercept is an x equals negative 3. And over here, when I add 1 to both sides, I get x equals positive 1. Now, you may be thinking, oh, that looks like the axis of symmetry. But remember, when we found these numbers, it was specifically for y equals 0. So when we plot negative 3 and positive 1, those are just going to be dots on our x-axis. So here's a negative 3, and here's a positive 1. And I want to point out to you before going further, you'll notice they are symmetric across the axis of symmetry. All right. Now, the next point, the y-intercept, of course, is the easiest one. The y-intercept is simply 3. So, I'm sorry, negative 3 in this case. The y-intercept is the point 0, c, which in this case is 0, negative 3. And again, that's in a previous video. If you need to go back and look at that, that would be the work from this past Monday. Maybe want to check that out. Anyway, the point 0, negative 3 is going to be on the y-axis. That's why it's called the y-intercept. Negative 3 is here. All right, so I now have 4 points. I need to graph one more. And I bet most of you can tell already that point's going to be here. Now, let me just show you how that works. The reason that works is this y-intercept is exactly 1 unit away from the axis of symmetry. So to be balanced, I go 1 more unit over. And then that does give me that symmetric point. So not only do I get that point, but I now have 5 points, and that's all I need to graph a parabola accurately. You could, of course, find more, and sometimes you might need to, but for now, this is going to be enough. I'm going to do my best to draw a smooth curve. Remember, it's not pointy, and it's it doesn't become straight at the sides. Let me see if I can make this a little bit nicer. It should look something like this, where the arrows tell me it keeps going. And again, notice it's pretty pointy, but it's not a V shape at the bottom. It is kind of curved. So that's what my graph would look like. And of course, in reality, it extends further. Keeps going, always up and out. So that's how we would use special points to completely graph a parabola. I know this was our longest video, so, if you need to pause while you're watching it, do what you need to do. But yeah, that's a good graph. All right, thank you guys.